Welcome. In this video, we will explore the importance of UAV sensor maintenance and how it influences flight performance and safety. Sensors such as the gyroscope, accelerometer, electronic compass, barometer, and GPS play an essential role in drone stability and navigation accuracy. We will analyze effective methods for cleaning, calibrating, and diagnosing sensors to prevent errors that could affect UAV functionality. Proper UAV sensor maintenance is essential for optimal performance, flight accuracy, and accident prevention. This includes physical inspection, cleaning, periodic calibration, and problem diagnosis. Periodic sensor maintenance ensures optimal functioning. Follow these steps for each sensor type. Checking the gyroscope and accelerometer. Connect the UAV to the configuration software. In the Sensor tab, check if the gyroscope and accelerometer values change correctly when the drone's position is adjusted. If the UAV behaves imprecisely or oscillates in flight, the IMU may be miscalibrated. Maintenance. Clean the electronic board and IMU with isopropyl alcohol. Avoid excessive vibrations by using damping pads for mounting. Keep the UAV at optimal temperatures between 0 degrees Celsius and 40 degrees Celsius. Recalibration. Place the UAV on a flat, stable surface. Access the IMU calibration option in the software. Verify that the accelerometer values indicate 0 degrees on X and Y and -1 degree on Z. Checking the magnetometer. In the UAV software, compare the compass data with a real compass. If the indicated direction is incorrect or changes abruptly, the magnetometer may be affected by interference. Magnetometer maintenance. Avoid placing the magnetometer near power cables, ESCs, or motors. Protect it from strong magnetic fields, magnets, and high-voltage wires. Mount it at least 10 to 15 centimeters away from electromagnetic noise sources. Magnetometer recalibration. Connect the UAV to the software. Select the compass calibration option and rotate the UAV 360 degrees on each axis. Confirm the calibration and verify the direction in the software. Checking the barometer. In the UAV software, check if the displayed altitude changes when manually raising the UAV. If the values fluctuate wildly, the barometer may be affected by air currents or extreme temperatures. Barometer maintenance. Place a protective foam over the sensor to reduce airflow interference. Avoid excessive moisture and keep the sensor clean and dust-free. Barometer recalibration. Keep the UAV in a draft-free area. We access the barometer calibration option in the software and wait for the altitude values to calibrate. GPS verification. In the UAV software, we check the number of detected satellites. There should be at least 6 to 8 for stability. If the UAV frequently loses GPS signal, it may be affected by radio frequency interference. GPS maintenance. We avoid flying in areas with electromagnetic interference, tall buildings, or radio towers. We install the GPS antenna away from video transmission and other electronic equipment. GPS recalibration. We activate the cold start option in the software to reset the GPS memory. We leave the UAV outdoors for 10 to 15 minutes to establish a connection with satellites. Obstacle avoidance sensor verification. We test the sensors by bringing the UAV close to an object and checking if the distance is correctly detected. If the reported distances are incorrect, the sensor may be dirty or blocked. Obstacle avoidance sensor maintenance. We clean the sensor surface with a soft cloth and isopropyl alcohol. We avoid direct exposure to strong sunlight. We test in different environments to detect possible interference. Obstacle avoidance sensor recalibration. We place the UAV at a fixed distance from a wall or obstacle. We check in the software if the reported value is correct. Then we adjust the sensor sensitivity and settings. In conclusion, we perform checks before each flight. We calibrate the sensors periodically, especially after an accident or temperature changes. We keep the sensors clean and protected from dust, moisture, and mechanical shocks. We avoid electromagnetic interference and install sensors properly.